We're going to talk a little bit more about what a relation and what a function is, and this is, I think, is going to help us to understand that just a little bit more. So let's look at the first part of the instruction here.
In this problem, you will identify functions using mapping diagrams. Part A. Identify the domain and range of the relation. Represent the relation with a mapping diagram. Is the relation a function?
So we haven't seen mapping diagrams yet, but that's what we're going to look at here. But we have talked about what makes a function and what not makes a function. Because remember when I showed you guys how to make the graphs, and I said if you drew a vertical line through it, it wasn't going to be a function. But we're going to show you what that means. And I explained it a little bit at one point, but I think this will help us understand a little bit more. And when they say we're going to talk about this in a second, but the domain is just the x values are the domain. So we'll move ahead here and see what we have to say about that.
When is a relation not a function? A function maps each domain value to exactly one range value. So, a relation that maps a domain value to more than one range value cannot be a function.
That's just really a fancy way of saying that for every x, you have only one possible answer as a y.
The domain contains the x coordinates. The domain is -2, 0, 4, 5. The range contains the y coordinates. The range is 5/10, 2 5/10, 6 5/10. Represent the relation with a mapping diagram by mapping values in the domain to values in the range.
So what we just showed here is that domain is like our x values and the range is like our y values when we make those tables in class. And then we use those as our ordered pairs. That's really all we're doing here. We're just doing it as a mapping diagram. And so what they're going to do is they're going to connect them with some lines here.
Represent each ordered pair with an arrow in the mapping diagram. -2 maps to 5/10. 0 maps to 2 5/10. 4 maps to 6 5/10. And 5 also maps to 2 5/10. Each domain value is mapped to only one range value. So the relation is a function.
So,
Notice that a relation can map two domain values to the same range value and still be a function.
Yeah, so really just you're making sure that each of the values in the domain only goes to 1 in the range. So that's really all it is.
Part B. Identify the domain and range of the relation. Represent the relation with a mapping diagram. Is the relation a function?
So we're just going to do the same thing here. We're going to make that mapping diagram and see if it works out for us.
The domain contains the x coordinates. The domain is 4, 5, 6. The range contains the y coordinates. The range is 3, 4, 5, 8. Represent each ordered pair with an arrow in the mapping diagram. 6 maps to 5. 4 maps to 3. 6 maps to 4. And 5 maps to 8. Remember, a relation cannot be a function if it maps a domain value to more than one range value. The domain value 6 is mapped to 2 range values. So the relation is not a function.
So see, that's different than when you have, say, 2 different numbers going to, like, say, 3 or 4 in the range, right? So there's two mappings going from 6, so that's not possible for a function.
Now it's your turn.
So we'll do the same thing here. So go ahead and make yourself a little mapping diagram, see what you get, see if any of the domains map to the two different numbers in the range, and we'll come back and check and see what you got. So hopefully you paused and you had a second to make your mapping diagram, and here are two possible answers for that mapping diagram, and see if yours works to one of these, and then we'll see what the correct answer is. So in this case, right, 4.2 mapped to two different values in the range, so it can't be a function. And that's really the key concept here, is this: you can't have two arrows coming out of the x's or domain into the range. I don't think really, I guess we could show the solution page, but you know, it was, if you plugged your values in and you represented it, you should be fine. Okay, so this is it for this one. Come back for the second part of this lecture series. Okay.